We are back. Welcome to the Unriveted podcast, where we dial in on technology intersections of digital transformation, artificial intelligence, and people. Our goal with this podcast is to talk about topics from the past, the present, and the future as they apply to the modernization of process automation. This episode, again, is brought to you by Wingnut Investments, where tightening their ROI, John, as we always know, is just a thumb screw away. So, John, what do you think we're going to talk about today?
Well, Martin, I am glad you asked, and I am excited that today on the Unriveted podcast, we have our first guest that we have invited for this conversation in the area of observability and explainability in artificial intelligence. Would you care to do the introduction, Martin?
Absolutely. Thank you, John. Well, let's welcome to the screen our first guest on Unriveted. His name is Botty, and Botty is the co-founder and CEO of Tenyks.ai. Botty, welcome.
Thank you very much for having me, guys. Martin, John, pleasure to be here with you today.
Good.
Awesome.
We're glad to have you.
That makes it even more fun.
Yeah. It will make it as fun as we can make it. So Botty, make sure I'm saying your name correct. You go by Botty Dimanov. Is that correct?
Botty Dimanov. Yes, that's correct.
Excellent. And Botty, you are currently sitting in where in the world?
This is Sofia, Bulgaria, country of adventure and very delicious food, by the way. So if you ever want to enjoy a good meal and ski in the meantime, this is the place for you.
Wow.
Put it on my list of upcoming travel excursions.
Absolutely.
Awesome.
So Botty, we're ready to DoorDash some meals from Bulgaria here. So hopefully the delivery will be still warm when it arrives.
Some wine, by the way. Yeah, but what can come in good quality is I hear after SBB's little shenanigans, the wine industry has been hit, and Bulgaria is famous for the wine. So maybe you're going to get some Bulgarian wine soon.
We look forward to that. John and I pulled up some factoids on you. We had to get them translated, and hopefully the translations came through fine for us. But I believe Forbes Bulgaria says you're a combination of Elon Musk and Thomas Edison. That is amazing. What does that actually mean?
Well, I think they want to say I aspire to be a combination of Elon and Edison. But what it means is I often tell people when I was coming up with the idea for Tenyks, I had this, I call it early life crisis. I wanted to be two people at the same time. I wanted to be the founder, the entrepreneur who takes an industry and completely reinvents that by building a company. But also I wanted to be the inventor, the Thomas Edison, the person who tinkers in his basement and comes up with the light bulb, which then changes the world for centuries. And I'm glad to say finally, after 6 years of different endeavors, they both culminated in the creation of Tenyks.
That's awesome. And where did the idea of Tenyks actually originate?
Pretty much all of our friends from university when we were doing our PhD in Cambridge, and a lot of our friends who went to these accelerators like YC or Entrepreneurs First started deep learning companies, right? AI companies. They wanted to apply the technology to solve a real world problem. But what they faced was the stark reality that 85% of the projects they started failed. And they didn't fail because of a lack of a use case. They failed because it took around 9 months to get a machine learning model to production. Mm-hmm. And we really wanted to go and solve this problem by helping people understand why are the models failing and what they can do in order to fix them. It's a little bit like a debugger. And I tell people ML right now is where software development was when we did the punch cards in the 1950s. You get feedback after 2 days. It is just really tough. And now you have, IDEs.
Wait.
PyCharm and VS Code.
Botty, I got to pause you, man. Have you seen punch cards?
Go for it, Martin. I have actually seen punch cards.
Martin's career actually started out in punch cards.
No way! It started with that. This is glorious.
Oh my goodness.
I mean, I've seen a very old project. I've never used one, but
yeah, you type up your program, you stack up the empty cards, it goes, it punts it to a machine, and it's a stack. And I don't know what to say in proper words to not use any four-letter superlatives, but if you drop that stack of cards and they go out of order, your whole program is broken. It's amazing. So
yes.
tell me it's not so. Machine learning isn't that primitive.
Well, the way we develop it is that primitive. That's the sad part. We just don't. I mean, maybe it's sad, maybe it's exciting. I would say it's exciting because we actually gives an opportunity to us and to many other people who are in the field to build the tools of the future, right? I mean, today we have all sorts of platforms. You have like CI/CD and GitLab and GitHub and all these different products which make software development fun. I mean, today Microsoft launched Copilot across all other products, and we're gonna see the same thing in AI development.
Yeah. Can I ask, how did you get interested? How did you get interested and involved in machine learning? I'm interested in how you went from, your education into that field, and how you got to where you are today.
Oh, thank you for that question. What happened for me is I had this very inspiring professor, I would say. And this man was a machine learning professor, of course, but he gave us this vision that every groundbreaking technology needs a category defining product. So we used to have computers, they have GUI operating systems. We then had the internet, and guess who came up? It was the search engines and Google. And now we have the new technology revolution, which is the artificial intelligence. But what is this category defining product for AI gonna be? That was the question he posed on us, and he wanted us to pursue an answer. And I didn't want just to be one of the the developers of this. I want to be one of the creators of these pioneering products which become category defining. But I knew nothing about AI. I had one module in machine learning. So I went to Cambridge to do a master's in machine learning and computer vision and NLP, and that's where I really got hooked because I saw the potential of the technology.
Good, yeah, I understand. I'm surprised that that they have that they had a degree program in that field, because it seems like a lot of universities, almost every university now seems to have a degree in. Well, computer science has been around for a long time, but actual fields of study in artificial intelligence and machine learning, you go back 5 or 10 years and you probably couldn't find any colleges or universities anywhere in the world that were offering that field. And now I bet you, based on what you just said, they're probably all over the place. So maybe you were one of the first pioneers to go through one of those programs, and your experience in there seems like it led you to this place where you are today. Quick question. So it's Tenyks.ai.
Right.
Am I pronouncing that right? Tenyks. Okay.
It's just Tenyks. It's just Tenyks.
Just Tenyks. Okay. Just Tenyks. I gotcha. I did a little investigating myself and on your website, prior to the call, so I'd have a couple of questions to give you. But one thing that I'm interested in is that Tenyks seems to be focused specifically on kind of the niche area of computer vision. And I think I also read that you called it an ML ops doctor for computer vision models. I don't know if that's a direct quote, but I'm interested, if you could give us kind of a high level overview of what being an ML ops doctor means, specifically in computer vision, which basically describes Tenyks.
Yeah, very happy to share. And I think it's a combination between an MLOps platform and a doctor for AI. But essentially what we do is we diagnose the model failures, similarly to how a doctor would diagnose whether you have a sickness, right? And humans get sick, we have coughs, we have temperature, and usually these are symptoms of an underlying condition. And similarly, in machine learning, models start to underperform, they break, just like any other software or even a machine. And then the difficulty many machine learning engineers face these days is that they don't really know how to resolve these problems. They have to throw spaghetti at the wall and look for different ways to make their models better. But that process can take sometimes months, sometimes it can take quarters. And really what we help them understand is they can boil down the problem to, is it a problem with the data set? So do we need to increase the quality of our data? Or is it a problem with our annotations? Do we need to re-annotate, change our annotation process or our taxonomy? Or is it the thing that most machine learning engineers want to spend their time on, the actual model? And then we need to do regularization, hyperparameter tuning, attention, change to transformers or something like that. And at least you have an idea of where you need to go in order to fix your problem.
Gotcha. So that, and thanks for that explanation. And that's obviously, kind of the entire rationale for ML ops, right? Is that when you deploy a machine learning model, it doesn't work. The day that you deploy it, it's just like what they say when you drive a new car off of a car lot, is that it immediately loses like half of its value. The analogy is that a machine learning model that you deploy today, in a week or a month or a year, depending on what it's designed for predicting, is not going to be able to do that well, because things change over time and the data that we use changes over time. So I'm interested from that perspective, things about computer vision in general. What would you say are some of the things that what can happen in images or video that can cause a computer vision model to, have to, need to be updated using CI/CD MLOps processes?
Oh, absolutely. Thanks for opening this interesting discussion. So there are multiple things that can happen to kind of computer vision model. One of the things is that the environment changes. So great examples are maybe the autonomous vehicles, right? So an autonomous vehicle is moving and it's trained based on some certain lighting conditions. And let's say it enters a tunnel. Tunnel has different exposures of the lights. It's slightly dark in some patches, lighter in other patches, and the algorithms can get very confused. Or maybe it's trained in an environment where the sun wasn't never pointed straight into the camera, and if it points straight into the camera, then it starts seeing very different things. Or it was never trained in an environment where there was fog or rain or snow or some other kind of weather condition. And then the problem is, most of the time people do record in these scenarios, but they don't record situations when something particular happens. For example, there is a truck which was turned over, and then there is a sun glaring into the camera, and these two things together have never happened in the dataset before.
So this is one of the reasons why creating autonomous vehicles has been such a challenge, is because the environments that vehicles operate in are so different everywhere you go in the world. You have changing, landscapes, which, for the most part, if you live in a mountainous area, it's probably going to stay mountainous. But if you live in an area where the seasons change, maybe one day you wake up and everything's covered in snow. So maybe the shapes of, traffic signs or vehicles might change, which means the computer vision model might, know what a car looks like when it's not covered in snow, for example. But when it snows the next day and you get into your autonomous vehicle to go to work, maybe it thinks a snow-covered car is a house, or maybe it thinks a snowman is a real person. I don't think. Hopefully, nobody out there is actually shaped like an actual snowman. But you get. Yeah, I'm joking partially, but also, it sounds like you agree with some of that.
It could absolutely happen, right? Because some algorithms learn to detect the face for a human. I'll tell you, very, very common mistakes on some of the data sets we've seen is that if a person is not facing the camera, so for some reason, maybe somebody shouted at them or so they turn their head slightly, and then it's not detected, it's not predicted, because the algorithm uses the face as one of the core features for detecting that something is a person.
Right.
And then
All
what
right.
does a snowman have? It has like eyes and something which imitate that.
So you don't have any people in your neighborhood, Martin, that have a corncob pipe, a nose made out of a carrot, and two eyes made out of coal, right? Is that? I'm not describing anyone in your neighborhood, I hope.
They sometimes call me Frosty, but John, I can appreciate it. In fact, the scenario that Botty and I actually first conversed on before today was actually a case, I believe it was, think about cameras trying to grab inventory in a retail environment. I think we were talking about that topic, and the cameras often in a retail environment are usually up high in the air, and they're usually for security purposes, not for inventory. So we were also then talking about how the incident angle between the camera and items on a shelf or in bins, it'd be very difficult to detect all the quantity of objects correctly. And that's a dilemma. So then you get into the next level. You have robots with cameras going around. Well, that's also cost formidable for many small operations to even consider anything like that to go roving around. But then you've got sensors that can detect RFID or other objects. If you go into some clothing stores, you can take a bunch of the clothing, drop it in this bin, and it magically catches all the IDs off the tags, and you can inventory that way. And that's a cool methodology also. So Botty's been behind some pretty cool stuff we were talking about. But ultimately, Botty, I'm really curious, your presence and how you sell your product line. Tell me what the hook is. How do you get introduced in the sales cycle? What are some of the challenges to getting into the sales cycle for you today?
Well, I mean, that's quite interesting, because it really depends on the persona, one, and two, it also depends on the particular stakeholder, right? So there are companies which are much more advanced in their development life cycle. So, for example, it could be somebody who has a large data set, and this large data set, it's not delivering the performance they want to deliver. They haven't labeled the whole thing because it's maybe millions, sometimes billions of images. And then the real value is that you can actually understand from this large data set what are the core pieces of this data set we need to focus on and source in order to improve the performance of our algorithms. And that really benefits in two ways. One is that you reduce your compute costs, because you don't need to train on millions of images. You only train on a little subset of that. And sometimes it could be 50%, sometimes it could be 80%. But it also reduces a lot of the labeling and data collection costs, which is another huge kind of expense line on the balance sheet for ML companies. So that's the value proposition for large companies. And then there's a value proposition for kind of companies which are starting out, they're prototyping things, they need to get to a model very quickly. And then really the value proposition is about the speed of development. And the speed of development can be accelerated around 6 times in one of a case study that we're gonna release soon, in the sense that we can take a process which sometimes can take maybe 9 months, we can decrease that to a few weeks in the aspect of understanding what are really the failures, what's blocking us, and how can we resolve the gaps to get our model to production.
Some good cost savings, some good time savings. Yep.
Thank you.
I got another question for you, Botty. And so I'll give you a little background on this. So Martin and I, a couple of weeks ago, did a few Unriveted podcasts on ChatGPT from OpenAI, which pretty much everyone in the world has been talking about. Even though generative AI language transformer models have been around for years, but for whatever reason, ChatGPT was the one that everyone started to pay attention to. And no sooner did that
good
happen
marketing,
that it's good marketing. Yeah. And they got a lot of money, backing them up, and big tech names. But as soon as, everyone starts getting overwhelmed by ChatGPT, just the other day, OpenAI put out GPT-4. And my previous experience with before ChatGPT was GPT-3. So I had used GPT-3 for, giving a text prompt, and then you get, some response. And what I'm getting at is a lot of people in the AI ML world are starting to see these massive, quantum leaps, so to speak, in AI technology. And they're like, oh boy, like we thought we were the ones that were going to be, taking away jobs. Not like people are out there to do that. But my question is, when you see these new technologies, how do you think that will impact your business or what you do specifically with computer vision at 10x? Do you think someday we'll ever have a product that could just automatically do everything 10x does? Or do you still think there will be a need for tools like that to improve kind of like the training and development process of these models?
I got it. I mean, if I summarize your question to, what is your view on how ChatGPT is going to affect 10x's product line, essentially? One thing, we actually see it as a very exciting opportunity. It's a very exciting opportunity because one, we can leverage this technology as well. I don't think it's going to automate us first. And second, actually, our vision for the future is much more that a new type of a role is going to emerge. And we call this role, jokingly, it's going to be a bit like the AI psychologist. And why do I say the AI psychologist? We believe it's going to be a little bit like the Minority Report movie where Tom Cruise, interacts with the data and, flips some switches and turns on things and, connects them and boom, he can see the future and, solve crime. But we really believe that when you start building more and more complex AI applications, it's going to come to the ability to interact with the data and have a conversation, but really an interactive conversation of, okay, so I give you 1 million data points. Maybe it's images, maybe it's, text, maybe it's videos. And then what did you actually extract? What did you learn? How do you understand what I told you? And we're going to have this conversation where the AI is going to, version we're going to have in that point is going to reply back to us and it's going to explain what are the features it's picking up, how is it making the decisions, how is it reaching to the conclusions that it's making, and then we'll have the opportunity to interact with that and adjust it just as we're doing with by teaching children. That's our vision, and we're starting with a product which helps machine learning engineers, and we really believe that that's probably the first place to start, but gradually this role is going to evolve and we will evolve with that.
Good. So it sounds like you have, you're not too frightened that anytime in the near future, AI is going to come knocking on your door and say, we'll take it from here.
We're excited. Honestly, I don't think AI is going to be able to automate humans. We're always going to be in the situations where we're going to have to make the judgment calls, the value beliefs. As long as AI remains in the aspect of a logical, statistical system, it's not going to have emotion. And people make decisions for emotional reasons. We justify with logic, but we make decisions from emotion.
This has been awesome. Oh, this has been awesome listening. I want to say thank you so much for joining us today. It's been a real pleasure. If our listeners want to get in touch with you, how can they do so?
Best way to reach me is over LinkedIn, and I would love to connect.
Thank you, Botty. This has been awesome having you here. We'll put a link to your LinkedIn profile in our output. And thank you for joining the Unriveted podcast. Thanks all.
Thanks for having me on the Unriveted podcast. See you soon.